Now let's understand the deploying Kubernetes application. Now, when you deploy an application in Kubernetes, you essentially deploy a containerized application in Kubernetes. Now, when you deploy a container in Kubernetes, because Kubernetes don't run container directly, you can't really deploy a container directly. What you do, you basically put the container inside of a pod and deploy that pod. But what happens when a pod goes down? Or if you need more pod for the same application, how do you create multiple pods or load balance those pods? Are the key question which you need to answer when you deploy a pod within Kubernetes. And to solve those questions, the problems you might face while we run multiple pods is by using something called deployment. Now, it is a configuration which talks about how a container within a pod will run behind a deployment instruction. So it essentially is a wrapper around pod to tell more than what you need to run multiple pods in a typical application scenario. Now, if you look into the deployment, right, it is about creating, updating, scaling your number of pods you run for your application. Now, based on the instruction given in the deployment, the Kubernetes control plane takes care of scheduling the application instance and deploy it in either one or more nodes, depending on the instruction specifically given. So let's say if you have to run 10 pods and in the Kubernetes cluster, a single node which cannot host all those 10 pods because there are other pods running, it'll essentially make sure that your remaining pods will be distributed in other nodes. So that is typically the control plane and the Kubernetes scheduler activity, which happens behind the scene through the deployment instruction given. Now, it also has a capability of self-healing, which means that imagine one node goes down from your Kubernetes cluster. That's a machine, right? And that hosts a lot of pods. As soon as it goes down, immediately the Kubernetes control plane gets to know about the health of that node and the pod inside that node. And it tells the backend of the Kubernetes that there is a problem. Now, there could be, let's say, out of 10 pods which you decided, 3 pods are running in that node. If that is the case, then it will immediately take those 3 pods and create it in the available nodes within that same cluster, right? So that is something which happens on a constant basis. So deployment keeps monitoring all the pod within that same deployment level. So it uses something called a level and selector, which we will discuss in detail in our upcoming session. But essentially, all the pod will have certain level defined, and deployment will keep monitoring those level to understand the health of that pod. And once one of them goes down, the deployment will pick it up from there and redeploy that pod to some other node, making sure the state, the desired number of pods you need remains constant all the time. This self-healing mechanism can happen due to the machine failure, due to the hardware limitation, due to many different things. We don't know. But imagine pod going down for some reason. Then deployment is the key player here to ensure that it is up and running all the time. When you deploy an application through deployment, you can define the deployment manifest in an YAML file, and you say that kubectl apply or kubectl create, which will essentially create the object in the Kubernetes and it will start the app in the worker node, right? And deployment basically keeps monitoring those pods which gets generated out of this instruction file or the YAML file. So what you see is that through this kubectl, you can also deploy the deployment object, which essentially holds the Kubernetes pod, which essentially holds the container. So that's the hierarchy. So you need to have that kubectl installed in your local machine from where you need to connect to the Kubernetes. So the kubectl is a command line interface, which is the way to interact with Kubernetes, right? This is one of the ways to interact with Kubernetes. It's not the only way, but it's one of the ways. So you can have your laptop with a kubectl, and then you can connect to your backend server, which basically hosts the Kubernetes cluster. It can be a public cloud, it can be a private cloud, it can be another machine, but you need to get connected to the network to be able to reach to that machine. And the kubectl will be able to now interact with that Kubernetes. So if you install the kubectl and connect this Kubernetes cluster you want to work on, you can get the information about the node, you can read the version, etc. So you can also get quite a lot of inline help, which are pretty helpful in terms of figuring things out. Now you notice here, if you do not have an YAML file, you can still create a deployment using this kubectl create deployment command, where you give the name as my nginx, right? That's the name you provide. And after you provide the my nginx as a name, you give the image. So here it is going to download the nginx image, create a container, run it within a pod, and then it'll be wrapped around the deployment. But because we did not mention anything about how many replicas we need, it's going to go ahead and create single replica by default. So that's what you will see inside the created deployment object. If you have an YAML file which has a definition already created in form of YAML, you can simply say kubectl apply -f and the file name. You can also use kubectl create -f and the file name that does the same thing. You can also check the existing deployment by using kubectl get deployment. Get deployments will give you the list of deployments, all of them. But if you want to point to an existing deployment, you can also view by using name. If you have a deployment running behind a service, right? That's how the IP address is exposed. So you can actually use that service name :80 for Nginx, because Nginx is a HTTP server. So it uses port 80 to reach out to that Nginx from your master node, right? Using curl command. We haven't done a lot of work around, let's say, exposing it outside of the cluster. So if you have configured all your host and etc., you'll be also able to read it from outside, but that's out of the scope for this discussion. Now, a deployment YAML can also come from a HTTP URL. So if you, let's say, have a GitHub repo where your YAML files are located, you can actually say kubectl apply and give the full path of the file, and that will basically give you the YAML back into your system and will help you create that. Now you can see that we are using raw.github user content. That's the actual file. So you need to get that file path when you provide this information, and then it should be able to create. So there are a bunch of examples available in the Kubernetes official documentation in terms of what URL you can use to deploy what kind of resources, and you will get them all from there. The Kubernetes namespace is a very important topic, which essentially helps you segregate things. So you can have a Kubernetes cluster, which is being used by multiple different groups within a same company. You can also be a provider who is selling the Kubernetes service to outside world, and then you allow one customer use one namespace. Okay, so you basically segregate everything within the namespace. allow only one namespace and people can come and use that namespace to be able to create their own resources. And that namespace is a sort of like a boundary for them, right? So it basically have got everything you need to run on pods, deployments, services, etc. within a namespace. If you do not have any namespace and just go ahead and you start working on it, they use a default namespace which can be configured, and you can change that behavior to the kubectl config change. Now, there is always a default namespace, and the namespace is generally created by the cluster operator. You can also create your own namespace if you wish to create the namespace. To see all the namespaces you have access to, you can use kubectl get namespace, and that will get you the list of namespaces available, and you will find some existing Kubernetes namespaces already available, like default kube-system, kube-public, etc. in your machine available. With the first time brand new Kubernetes cluster, you still will find a few namespaces already there. And then you can create your own namespace and start working on it. Now, the kube system namespace is being used by the Kubernetes component and should not be used for application resources. So that's one thing you need to remember. So you should not be creating a pod inside that namespace. A similar thing for the kube public, it is used for public resources and also not advised to use this namespace for any application specific resource like your pod, your deployment, or your service. The default namespace is what we generally use, right? Every Kubernetes resource store is stored by default in the default namespace. Entire cluster is in default until new namespaces are added, right? So you can live without creating any namespace and then still be able to create the pod within the Kubernetes cluster because there is a default namespace which is default for you and available for the creation. So that's why your experience is seamless. Now, you can have multiple Kubernetes namespaces for multiple different things, which basically helps you have a resource control, gives you the performance benefit, and creates an isolation layer so that you can, let's say, create a pod namespace for all the pod related deployment. If you have, let's say, dev namespace for dev related deployment, you can delete a namespace and everything else inside that namespace will be deleted for you. It's easy to clean up. And you can run multiple different environments if you group them inside separate namespaces. Helps you design that way. Now, to create a namespace, it's fairly simple. Use kubectl create namespace and the namespace name. It's a simple English term, and it is generally an alphanumeric character. I think you can have a namespace with any English letter, mostly smaller cases. You can just give a name and that will be the namespace. You can use dash, and I've seen that cube dash public, cube dash whatever you have seen before are the default namespaces. So you can get that namespace. You can even create a namespace using YAML file definition. So the kind is namespace and the metadata is name. That's all you need. You don't need much information. So you can have this YAML and pass it as your CI/CD pipeline to create that namespace. So you basically have that namespace kind of created by different means. Now, kubectl by default points to the default context. Now, imagine that you created a new namespace and then you start working on the namespace, and from now onwards, you will be working on that namespace. Every time, for every command you type in the kubectl, you need to provide the namespace as part of it to be able to work on that namespace in terms of creating a resource, in terms of even viewing a resource. To avoid those repeat typing, you can actually switch your kubectl context into the namespace you want to work on now onwards. So for example, if you create a dev namespace and then you want to continue working on the dev namespace, you can set the context of your kubectl config So you saying that kubectl config set context dash dash current, and then you provide the namespace equal to dev. So that way the namespace is gonna go ahead and create the resources within that boundary. So you have that capability available inside the namespace. Now you have this pod deployment within a namespace. So you can go ahead and create a deployment just like that. And whatever the default namespace is, it'll go ahead and create that. But if you want to switch that and create that deployment into another namespace, you can always go ahead and choose this option of giving the namespace with -n, and it will go ahead and create that resource in that namespace. So that way, you'll be able to actually um, deploy resources in multiple different namespaces. And when you do that, you'll probably observe that you can create the same name resource because they're kind of sandboxed and separated. Now let's talk about Kubernetes levels and selectors. Kubernetes is a loosely coupled architecture. So when we have, let's say, deployment, and then it is monitoring set up pods, it does not have a direct connectivity with the pod. However, it observes the pod through a level and through selector. And one of the same thing happens also with services. So you create a deployment and then you create a service separately, but you say that this is my level which it needs to observe. So all the pods which deployment creates basically comes under that services and then stays behind that service under as a load balancer. So this is how level plays a critical role in Kubernetes, right? So it's a key value pair. So think about simple text, a key value pair, and it is to identify the object and its purpose of the object. So for example, if you have 5 different front-end component, then you probably mark them with a level front-end. And then if you have 2 database component, and then you provide them like DB as the level name, right? App is front end, app is DB, and then you can actually identify them based on the value you specify, right? So that's how you group them all in. It also helps you organize and select the subset of objects, right? So you can say that I want to bring out all my front end components, right? So you just filter out using the level, and then you get all the component which uses that level into your listing. And also one component can have more than one levels. So in that case, you can have set up levels for different purposes. So you can have level for whether it is a front end or back end. You can have level for a business group. You can have level for customer, all in the same element, right? Same Kubernetes object. So you can put multiple labels in that sense. So you can do multiple different filters. So one point in time, you want to figure out what all resources a specific customer solution is using. So you figure that out using the customer level. Later point in time, you want to find out like what is the department which is responsible for that. You get that, and you can do all those different filter criteria using that level. Now, level has a convention, right? It basically commonly used level like app, DB, etc. And each object level and key must be unique. That's one thing you need to remember, right? So it is obvious that you can have different level, but you need to ensure that levels are unique so that they are identifiable by the thing. So some of the examples, like you can have release with some name, component with some name, app with some name of the app, right? So you may have different app running in the Kubernetes cluster, right? So you want to identify what is this all about. So which app this component is part of, right? So you can mention that. You can create a level while you create that object. right? Or else you can put that in the YAML file as well. So when you use the YAML file, you can use something like levels in the metadata section of that. So this is where we are creating pod, and inside the levels, you basically get the multiple levels added, right? One is environment, is production, app is Nginx. So you essentially ensuring that what exactly this is doing. So you can one time you can filter it out using the environment level, another time you can filter it out with the app level. So you have two different purposes, but they are applied to the same pod, right? So you have multiple levels added to the pod. Now you can also create the level through the kubectl command line, CLI. And if you use that and you, let's say, create a deployment from the Nginx, like you just give a deployment name, image equal to Nginx, replica is whatever the number of replicas, and dash dash level. Here is what you can specify multiple levels separated by comma. So key equal to value and comma. There are a couple of things you need to remember about the level, the validity of the level. So it should be 63 characters or less. It can be also an empty level. So you can have just the key, let's say app equal to nothing. Okay, so that's also fine. If it is not empty, then it should begin and end with an alphanumeric character. So it can start with, let's say, number, or it can have a simple English character. It can also contain dash, underscore, dot, and alphanumeric things. So you cannot add special character inside that apart from these three allowed characters. Now, there are certain levels which you find inside Kubernetes, right? So if you see that show all levels, and you will find that all the levels coming up, right? And then you see over here, there are certain kind of level, which is like release table, release canary, environment dev, environment QA. So these are all typical identifier for the Kubernetes object, which is getting created over here. Now, there are few drawbacks of the Kubernetes level. So though we mainly focus on the benefit of the level, but these are the important thing you need to ensure. It doesn't guarantee the uniqueness of your component because it is just a metadata information. And it is in fact within the metadata component of the YAML file. So you will see that it is part of the metadata information. Um, Several items can have the same level in general. That's how you group them all together. Kubernetes Selector. Levels selector is a fundamental grouping primitive. It used to choose a group of objects. Kubernetes API offers two types of selectors: equality-based selector, set-based selectors. Now you can use this operators like equal to or equals or not equals, right? So scenario like environment equal to test, app not equal to front end. So you can do this kind of search criteria. Now, if you get the list of pods through kubectl get pods, and then use this switch called -L with the level, so it will only filter out all the pods which has this specific level. So out of your hundreds of pods you may have in your cluster, you can only figure out or get only the pods which has got this specific level. So that's what the selector does. And then you can also create a set-based selector, right? So you can use, say, a set of values possible with the set-based character, like in, not in, or exists, right? So you can just provide multiple values within that. Now, just to give an example of the set-based selectors, you can think of it like environment in production or QA. So you want to bring both of them. You can use that that way. You can also say that I don't want to fetch anything which is front end or back end. So tier not in, and then partition not equal to partition. So these are the typical way of uh, giving the filter criteria through the selector. So you can see that in E and V, that's a key in prod and Q. Prod and Q are generally the value for the environment key when you probably have created the pods, deployments, etc. and you have given this level while creating that. And then if you say dash dash show levels, it'll show all the levels along with each of these components, right?